Hello everyone, welcome to session 2 of ISTQB Foundation Level and Software Testing Training. Why is testing necessary? Software testing is necessary because a defect in software can cause harm to person, environment, or a company. So suppose let's take an example of road traffic control system. That's a software being developed by some company. And if there is a defect before after deploying that air traffic control, if it is not tested properly and there is a defect in the software, it might cause road accidents to occur. It might cause even death of the person. So that's harm for the person's life is at risk, and that's harm for the company. The other reason why testing is necessary is a defect can cause loss of money, time, or business. So suppose there are big e-commerce websites nowadays like eBay, Amazon. Have you ever thought if those sites are down for even for few hours, what is the revenue loss these companies face? So in case there is a defect for these e-commerce sites and these are down for a few hours, the, the business loss, the loss of money involved for Amazon and eBay is huge. It's in millions. So a defect for these e-commerce website can cause loss of money, time, and business. Third point why we do testing is because testing improves software quality. So once you start finding defects, or once you find that all the requirements design is proper and there are few issues or defects in the released software, you are more confident that the software that is being released is of good quality. And the fourth thing is testing reduces the risk. So there is always a risk involved in a software that is being released. So that risk is reduced when you test something properly, when you test the modules of the software properly, when you test the software, integrated software properly, the risk involved for the software as a whole is reduced because you find defects beforehand and those defects are fixed by developers and retested before the software is actually released into the market. Why do we test something? So we test something to ensure that it is okay, be it software, be it any electronic device or your mechanical device, your automobile. We test anything, any kind of device or software to ensure that it functions properly. It functions as it is expected to function. Testing is necessary because we all are human beings and human beings make mistakes during development. So if you are already working in IT company, so you know that while development there are a lot of errors or mistakes being made during the development process, or even during the requirements gathering or during the design phases. So testing is necessary because we all are human beings and there are errors introduced or mistakes introduced into the process. So we test something to ensure that those mistakes are being caught well in advance. Then some human errors do not impact much on our day-to-day life and can be ignored. However, some errors are so severe that they can break the whole system or software. So suppose you are just testing your family website or your personal blog, and there are some errors in the web server or on the front end. That doesn't matter much, it only affects you and some of your family members. But if you are if the error is made in air traffic control software or road traffic control software, it might impact human lives. So that's why the human errors can impact some of the human errors depending on the kind of software or system that is being developed can break the whole system or software. So in such situations, you need to take care that such errors are caught well in advance before deploying the software into the production environment. So these hospital applications, the software that is used in the intensive care units, air traffic controllers, road traffic softwares, these are all critical applications. So these should be tested well in advance to find out all the errors which could have been introduced during the development process before actually deploying this software into the production environment. Now let's take software systems context. So like I told, an error in your personal blog does not impact anyone else. It's just about you, your family, some of your friends maybe. So it doesn't affect anybody else. It doesn't risk anybody else's life, or it's not a critical application. An error in a business website may put off the company as it looks unprofessional. So if you are accessing some company website and it's down, or there are very basic grammatical errors, spelling errors on the business website, so it looks very unprofessional and it may put off the company. Then third thing is net banking websites or ATM should be thoroughly tested to maintain bank credibility. So suppose you are a net banking customer of NAB, ANZ, and you're trying to do some transactions and you're not able to perform the transaction. So it's very, for the bank credibility, it's not good. You are trying to use ATM. You tried on one ATM. It's not working. You went to another ATM. It's again not working due to some software errors. So these kind of errors in the software affect the bank credibility a lot. So in order to maintain bank credibility, these net banking applications, ATMs, your mobile applications, mobile banking applications needs to be always up and running to maintain a bank credibility. Otherwise, the bank will lose the customers. If your website is down every week for 4-5 hours, you will lose bank credibility and the customers will start moving to some other banks. Then air traffic control system is very critical system which needs to be thoroughly tested before doing a live deployment, because all the air traffic is dependent on it, and if there is one minor error in that system, it might cause a plane to crash, and hundreds of lives are at risk because of that. Then what are the causes of software defects? What exactly causes the software defects? So the first thing is people may make mistake during requirement gatherings. Okay, so we all are human beings and we can make mistake during any phase of the development of anything, of be it electronic device or your software. So we may make a mistake during requirements gathering phase. We missed some of the important requirement points that should have been there in the requirements specification. Then people may make mistake during the design. Then there may be mistakes during the coding phase as well. Okay, so due to these mistakes, there can be flaws in software, and these flaws are known as defects or bugs. So the main cause of software defects is the mistakes that are made in any phase of the software development lifecycle. Be it the requirements gathering phase, be it the design phase. A defect can get introduced in the high level design phase, a defect can get introduced in the low level design phase. A defect may get introduced during the coding. If a person is not very much experienced in coding or development, he might make basic errors during the coding. Or if the design is not proper, then even whatever right coding you do for that specific design doesn't makes it, there will be definitely defects because design itself is not fine. All right. So due to these mistakes, there can be flaws in software, and these flaws are known as defects or bugs. Then when do defects arise? So here I have made a figure which will explain how the defects arise. So I have 4 requirements here: requirement 1, 2, 3, and 4. And as we saw in the previous slide, that defects can arise in any phase, and defects arise due to the mistakes made by person into the requirements gathering phase, into the design phase, or into the development phase. Alright, so if we talk about requirement 1, a person who is gathering requirement, a business analyst who is gathering the requirements, gathered the correct requirement. Then as per the correct requirement, the person who is designing, who is doing the high level design of the solution or the software, he made the correct design. Then the person or the team which is building the software to meet the correct design, if they build it correctly, then the software will work as expected. After testing the software works as expected. So in the first case, in the requirement 1, correct software will be delivered. But if you take an example of requirement 2, business analyst gathered proper correct requirement. Then in the second phase, that is the design phase, correct design has been made for those requirements. But during the development phase, that is the third phase of SDLC, if there are mistakes in coding, mistakes in development, so mistakes in build, then software will be having defects in it, because the development that has been done in step 3 in development phase does not meet the correct design. So there will be defects, but those defects are the correctable defects. They can be caught by a software testing team during testing, and those defects will be raised and assigned to developer, and he'll fix it and he will retest, and those defects can be corrected. So in requirement 2 you can correct those defects. In the requirement 3, you have the correct requirement from business analyst. Then in the second phase, in the design phase, there are mistakes in the design itself. The design that has been made by the technical architect is not right. There are mistakes in the design itself. In the third phase, in the development phase, the software is built as per design, okay, because there are mistakes in design, but the developer is developing as per design. Developer will develop the code as per the design. He won't go and change the design. So he develops as per the design. But since there are mistakes in design, there will be software defects. So software has design defects because design is not right, and software has been built as per design. So software will be having design defects. In my recent experience, I have seen an extreme issue with the design. I was testing an e-commerce portal. There was a checkout being implemented. Checkout was designed improperly, and because of that, the developers who build the checkout functionality of an e-commerce website, they build it as per design, and now in the checkout functionality there are so many errors. If they fix one, there are two other new defects that arise in the checkout functionality. So what they have to do is they have to rebuild the design. So now in the same software that I was testing recently, they have to go back, redesign that checkout functionality, build it again as per the design, and then software design defects, only then software design defects can be resolved. Then in requirement 4, if there are mistakes in the requirement itself, requirements are not being gathered properly by the business analyst, there are mistakes there, then if a software is designed to meet the requirement, so that's where, if there are mistakes from the early phases, it's more severe. So if there are mistakes in requirement and you design to meet those requirements, then the build or the development is done as per the design, then the wrong software, completely wrong software will be delivered. And these defects won't be even caught by the IT team or the test team, because you are a tester is finding defects as per the requirements. Whatever requirements you see, whatever design that you have, you're not sure whether the requirement that are being given to you, or the mistakes in the requirement are not valid. So if the software is built as per the requirement, as per the design, then software test team cannot find those hidden defects, find those defects. These defects can be found only during the user acceptance test phase, when end user or the stakeholders, when they test and they figure out that no, this is not what we required, this is not what our requirement was. So in the requirement 4, defects are found in user acceptance test phase. So defects in all these 4 requirements, you can see defects can arise in any phase of software development. They can arise in requirements, in the design phase, in development phase, in any phases of the software development life cycle. What is the cost of defects? So in the previous slide, we have seen that a software defect can arise in any phase of the software development life cycle. And the later you find the defect in the software development life cycle, the more the cost is to fix that defect. So if you see the graph here, on the y-axis is the cost, and on the x-axis is your software development life cycle, with the requirements phase is the first phase, then design, coding, testing, production. Okay, so if a defect is found during the requirements phase, it costs very less to fix it, because you just need to modify the requirements accordingly, and because you have not designed for it, you have not put time and effort in coding it and testing it. But if the defect passes on from the requirements to design, and it's found at the design phase that the requirements are not right, it will cost you more. Similarly, as it moves to coding, testing, and production, the cost of finding defects and fixing defects increases over time. So suppose there is a defect in requirement, and you build and you designed as per the requirement, coding done as per the design, and the defect is found during the testing, that will require your requirement change completely or your design change completely. So you have wasted your coding time effort, your design, your test architect will technical architect will have to redesign, requirements have to be gathered again, redesign, coding again, and then testing again. So the cost of finding defects will increase exponentially as soon as you move further in your software development lifecycle. If a defect is found in a production environment, then it will cost even more. And if a production environment defect is a design defect, or it's a requirements issue, then you just need to modify the requirement, design, code, and again test again, and then again deploy. So cost of defect is much more as you move later into the software development lifecycle. So it's very easy to find and fix defects in the early phases of software development lifecycle. So that's why it is said that it is always advised start test early. So as soon as you start testing, as early as you start testing in your software development lifecycle, the more quality product you build. Then what is the role of software testing in software development, maintenance, and operations? Testing is important in development and maintenance to identify defects and bugs. Testing identifies any defects or bugs in a software. And once those defects or bugs are identified, they can be fixed, and a software without those basic defects or bugs can be released. A good quality software can be released. Testing reduces risk of software failures in operational environments. So what test team does is test team deploys the software exactly as per the operational environment before actually migrating it to the production environment, and then they populate the software with the test data and see how the software behaves in the test environment. So it reduces the risk of software failures in the operational environment. And testing improves quality of the software. So once test team starts testing, they start identifying defects. Those defects are fixed, retested, and then it gives a good confidence. And after those defects are found and fixed, so it gives a good confidence and improves quality of the software. And testing is also required as part of a contractual agreement or legal agreement. Okay, so suppose some company is developing air traffic control or road traffic control software, then testing is the basic. It's a part of contractual. It's a part of the release. It's an agreement. It's a legal requirement to go through all those predefined testing criteria, and the software should pass those predefined testing criteria before it is being deployed into the operational or production environment. So any high risk associated area, if you're developing any high risk associated software, that has contractual agreement or legal requirements to do testing. So testing is involved in those kind of high risk associated applications very much. And testing and quality. So testing helps to measure software quality. When you are testing an application, you find defects. Those defects are fixed, retested, and eventually after some testing cycles you start finding less defects. And once all those severe or high or critical defects have been fixed, it helps to measure the quality of the software. You can confidently say that the quality of software has improved from day one, from phase one. Okay, so testing helps to measure software quality. Testing provides confidence in software based on number of defects found. So in initial phases, if you are finding many defects in software, they are being fixed. And later phases, once those defects are fixed, in later phases of software development lifecycle, you find less number of defects. So you can say you are more confident on the software because you are not able to find any major or critical errors now. So it provides confidence in the software. Well-designed tests uncover most of the defects in software, and if the test pass, it gives more confidence in software quality. So if you have test cases which are well designed, you have used good test design techniques, so those defects uncover most of the defects in software. Those tests uncover most of the defects in software, and if your well-designed test cases pass, it gives you more confidence in the quality of the software. Testing also helps to find defects in software. Quality improves when those defects are fixed. So testing finds those defects. Software quality improves when those defects are assigned to developers and fixed and retested. So testing is an important part for improving the quality of the software. Then what is software quality? As per ISTQB, quality is the degree to which a component, system, or process meets specified requirements and our user customers' needs and expectations. Which means a software, so in a software test, in a software context, so quality is something if your system meets the requirements, your end user requirement, and it meets customer needs and expectation. When will I say that this product is of good quality? When it meets the specified requirement and it is fit for use for me. If I'm using some software, if that software is meeting my needs, it is good quality for me. It doesn't crash, it meets my requirement, it works perfectly fine even during even for long hours. That is a good quality product for me. All right, so software quality for developers and testers is that it meets specification, is technically good, and has few defects. But software quality for other stakeholders may be different because they also need value for money. So for developers and testers, if it meets specification, it's of technically very good quality and it has very few defects, then it is of good quality for software developers and testers. But if for other stakeholders, for the business stakeholders, it doesn't matter. I mean, if they just want an application or just want application with very basic functionality to achieve something, they don't want extremely high quality or extremely costly application for fulfilling just few things that they need. It's not good for them. It's not a value for money for them. Okay, so there are different viewpoints for software quality. One is attribute of product. How fit for use? Is it fit for use? How good is the development process? And is it value for money? Okay, so what attributes I need as an end user from a product? The product should meet that. It should be fit for use for me. The development process or the process by which that product has been developed should follow the standards, and it should be reasonably priced. So these are some of the viewpoints which define the quality of any software. Okay, so if I am looking for 4 things in any software, and there are 10 software that are providing all those 4 things, 4 software which are very easy or fit for use, so my list will come down to four softwares from those 10, and then I'll see which company it is from, and which will ensure that what kind of development process these companies is it a mature or a well-known company. Then I'll from those 4 I'll come down to say 3, and then I'll compare the price of those 3 softwares. The one that is reasonably priced and provides all the attributes, is fit for use, from good company, I'll buy that. Okay. Then what is the root cause analysis? Root cause analysis is finding the real reason for the failure. If a software you are testing fails, then you do root cause analysis to find the actual cause of that failure. Okay, so suppose you are testing a client server application, all right, and you are passing some parameters from the client, and your server is not responding. You are expecting some response from the server when you pass something from the client, but you are not getting those responses. You were getting those responses yesterday. So in order to find what has happened wrong, what happened wrong since yesterday, you need to do root cause analysis to figure out what exactly is the cause why you are not getting the response from the server. So there can be many reasons. There can be network issues, that your request is not at all being transferred to the server. That's one cause. Web server can be down. So wherever your server application sits, that web server can be down. There can be issues with the firewall at the server side or at the data center. There can be issues with the port. So these are some of the points. You do the brainstorming. So once you start getting some issues or failures, you do brainstorming with the team and figure out all the possible causes of the failure, all the root causes of the failure, and then you start figuring out. So then you start checking out if network is fine. Yes. So that's how you brainstorm, and then group them into categories, and then start checking what exactly caused the issue. So root cause analysis is finding the real reason for any failure or defect in software. And how much testing is enough? So the testing principle, there is one testing principle which says exhaustive testing is impossible. Why exhaustive testing is impossible? Because suppose you have one text field, one input field on your UI that only accepts one input, one digit. All right. So if you are testing that input field, there will be 10 scenarios if you are doing exhaustive testing for it. So 0 to 9. So it will accept one digit. So you have to test for all those 10 digits. Not only that, you need to test it for characters, lowercase alphabets, uppercase alphabets, some of the special characters, blank inputs. So total in all it comes to minimum 68 to 70 inputs, and it can be even more. So this is with just one input field on your UI. Suppose you have a text field which accepts two input fields, which accepts two-digit numbers. Then you have huge number of inputs to test with. So that's why it's said that exhaustive testing is impossible, because you cannot test all the valid or invalid scenarios um, for any application, because there are huge number of input fields. That's where you use your test design techniques, boundary value analysis, equivalence partition techniques, to figure out the scenarios, to figure out the boundary values and the scenarios that you'll be testing, which will cover most of that partition, the valid partition and invalid partition. I'll cover all those details in later sessions. Okay, so in order to figure out how much testing is enough, there's always risk assessment done to decide how much testing to do. If it is just your family blog, very minimal testing, or family website, very minimal testing. If it is a safety critical application, risk assessment is done based on different modules and then integrated system as a whole, and then decided where to focus more and how much testing should be done, what all scenarios needs to be covered, what are the standards that need to be followed. So it's based on risk assessment. So how much testing is enough is based on the risk assessment. You do risk assessment for the software and then decide the testing effort based on the risks associated with different modules of the software. So to conclude, in this session we learned why is testing necessary, what causes the software defects, then when do defects arise. Defects can arise in any phase of software development lifecycle, requirements, design, or coding phase. Then what is the cost of defects? What is the role of testing in software development, maintenance, and operations? Testing and quality, we saw how testing improves the quality. Then what is root cause analysis, and how much testing is enough. All right. Thank you.